Hey guys, welcome back to Bald Guy Sci. This will be our fourth episode in our ecology series. Today we're going to wrap up cycles in the ecosystem, so let's get right to it. The great Dr. Martin Luther King once said, "The time is always right to do the right thing." Now, you may wonder sometimes why I start my videos off with a quote. And the reason for that is character. Right now, our country, when this video is being filmed, is going through major turmoil over issues of racism in the midst of a global pandemic. And since the world will never lack for difficult circumstances, unfortunately, what it does lack is people who are willing to stand up and do the right thing at a difficult time. So it's always a good time to assess our character and to match our character with the times that we live in. So I hope that's a good challenge for you this morning. All right, well, we are looking at cycles in the ecosystem, and some of those cycles we've talked about before. We talked about energy cycling around and driving the process. We've talked about carbon dioxide and oxygen cycling back and forth between consumers and producers as they convert energy into forms that we can use or store it, and we can return that through respiration. We've talked a little bit about the water cycle and the four shun words of the water cycle, which are evaporation, condensation, precipitation, and collection. The last cycle is the nitrogen cycle. Nitrogen is abundant in our environment, but it's mostly in the form of nitrogen gas, or N2. That nitrogen gas forms a triple bond, which means it's three pairs of electrons being shared between nitrogen atoms to form a nitrogen molecule. Well, those triple bonds are really strong. And unfortunately, the nitrogen that we have available to us is not usable. Our bodies can't pull nitrogen out of the air to use it to build our cells and tissues in our body to help us grow and thrive. So the atmospheric nitrogen that is the most abundant source has to be fixed. Now, it can be fixed with the energy from lightning, which breaks apart those triple bonds and allows the nitrogen to bond to other things like oxygen and hydrogen, and then forms ammonia and nitrites or nitrates. But that process can also happen through bacteria that are in the soil or in the roots of some plants. Some plants have nodules or bumps on their roots, which are actually colonies of specific bacteria that they have a symbiotic relationship with, a mutualistic relationship where they provide a place to live for the bacteria and some resources, and the bacteria fix nitrogen so that they can grow things. Now, these are most commonly found on things that produce like beans and legumes because there's a high degree of nitrogen. But those plants, they allow nitrogen to enter the food chain. And so that entrance of nitrogen into the food chain is part of cycling. So we have fixing, which is changing nitrogen from one form to another, and we have cycling. So cycling happens from the atmospheric nitrogen into soil bacteria or plant root bacteria or lightning. Then it enters the food chain, and then it can go through decomposers or manure back into the soil. Other bacteria can cycle it back into the environment by converting it back into nitrogen gas.
Do we have to bring this crap? I'm sure there's crap where we're going.
This was a gift from my mother.
Okay, keep it moving,
Hey guys, so I'm out here in the countryside today just taking a quick shot of some of the things that illustrate everything we've been talking about with the energy and cycles in nature. Now, it's raining right now, so that's part of the water cycle, but off behind me, you might be able to see evidence of our windmills. So there's a lot of things around here that are actually taking in energy, water, and all of those concepts of cycles in the environment. Now, behind me also is a field, so I really haven't moved at all. I'm standing in the same spot, and there's a farmer's field behind me. The crops that are growing depend on the sun for energy, just like the windmill and the
and the creek behind me, the rain and the clouds. The thing that we want to think about here is that the water that might be on the ground or in a lake or in the ocean far off had to evaporate. And to evaporate, that required energy. And that energy comes from the sun ultimately. So when that water is evaporated and goes into the atmosphere, it leaves a void where cooler air has to rush in. Well, that cooler air, as it rushes in, is what we call wind. And that wind is what's driving those wind turbines behind me. And so we use that energy to create electricity. All right, guys, so literally just maybe 100 meters away, and you can see that this farmer's field behind me, the crops are just starting to grow. Yes, they require energy from the sun, and they require water from this rain cloud here. It's messing up my hair. But they also require nitrogen and carbon dioxide from the air. And so part of that nitrogen cycle means we need a way to get the nitrogen from the air into the soil where these plants can use it. And I'm really thankful that it's not raining very hard, but if this was a thunder and lightning storm, that's one of the ways that nitrogen gets fixed in order for plants to pull it out of the air and into themselves, which is what we call cycling. Now, this is going to be probably fed to a cow, and that cow will be fed in order to produce milk or cheese or dairy or food for us, right? And so cows can cycle that around from the nitrogen that ends up in the plant, goes into the cow, and then into us, and then obviously that waste goes back onto the field, and that can sort of restart the whole process. But all of that is going to be dependent on energy from the sun, the air moving around, and the water cycle. Well, this is a perfect example, these chickens in my backyard and the garden behind me, of how things are cycling around the ecosystem, the environment, right? So these chickens are getting basically a plant-based food. It's been crushed up into these little pellets, but they turn that into eggs and manure, right? So that manure in turn can go right back on the garden to fertilize the plants that I'm eating for food, but they all use energy from the sun, and they use water from rain, or I have a hose out here and a way to water the garden. So we need water, we need energy, which is food for the plants from the sun, but that becomes food for chickens. The chickens then produce waste and eggs, which is food for us. So we have nitrogen, which is in the air all around us, but it has to be converted into a form that plants can use to build protein. That happens in the soil, that happens with bacteria, but it also happens with the waste of animals, which can go back in and fertilize the soil to make the plants grow. So the nitrogen cycle, we have carbon dioxide, oxygen, we have energy, we have water. It all works together with food webs, food chains, to keep everything biotic and abiotic in balance. Excellent video.
All right, guys, that does it for our part 2 of our cycles in the ecosystem and number 4 video in our ecology series. Next time, we're going to look at changes in the communities of an ecosystem over time. But don't forget to click the like and the subscribe and the notification bell, and to share this video with somebody else. And until next time, this is Bald Guy signing off. We'll see you later.